Hey there everybody, Mr. Dickin here. In this video, we are going to be doing polynomial long division. I'm just going to give you the heads up right out the gate. These problems, they take a while to do, but even less thrilling is they take a lot of space to do these. So as you're writing them down, I wouldn't be surprised if we're dedicating half a sheet of notebook paper to one single problem. The actual math behind it is not necessarily difficult. We're just going to be doing the same iterative process over and over and over and over and over. We will be doing, after our warm-up, we'll be doing 5 examples here. If after the first 2, or heck, even maybe the first 1, if that's making sense to you, I'd say fast forward all the way down to maybe example 4 or 5. So if you're kind of following along right out the gate, fast forward it. So that way you don't, have to necessarily watch this entire video start to finish. Also, I've said this time and time again, if I'm talking too slowly, feel free to click the little gear in the bottom left corner or bottom right corner of the video and watch this at 1.5 or 2 times speed. All right. So let's do a quick little warm up with just straight up long division. And this is something that you guys probably have not done in years because since calculators came around, who the heck cares? But here's how long division works. We've got our divisor out here, and we're trying to figure out how many times can 12 go into 155. So we'll start off first by saying, can 12 go into our first digit of 1? And no, it can't. How about 15? Well, yeah, it can. And how many times can it go into the number 15? It can go into 15 one time. So I'll put a 1 above the 5. Then off to the side, I'm going to take that 1, and I'm going to multiply it by 12. And when I do that, I get 12. So now I will find the difference of those, and I get 3. The 5 then will drop down. So now I have to ask, okay, how many times does 12 go into 35? So I'm repeating this process over. Well, 12 can go into 35, not quite 3 times, so it can only go in 2 full times. So it can go into 35 2 times. So then I'm going to think to myself, okay, what is 2 times 12? If I threw 12 into that 2 times, I would get 24. We then subtract and find the difference. When we do that, we get 11. Now, normally when you have probably seen this before, you would throw a decimal and a bunch of zeros at the end. But what we could say is that there's a remainder of 11. So we would write this as 12 and 11 twelfths would be our answer. Okay? So what we're going to do is we're going to apply that to polynomials. And when we do this, there is a little bit of vocab. So we have a divisor, a dividend, a quotient, and the remainder. The divisor is what we're dividing by. The dividend is what we're dividing into. The quotient is your solution, your answer. And the remainder is whatever is left over. Right here, I have the note, if you get a remainder of 0, this means the divisor is a factor of the polynomial. So if we think of that as, in terms of real numbers, if I did 9 divided by 3, I get a clean, even number with no remainder. That means 3 is a factor of 9. If I did 24 divided by 4, I would get 6 as my answer without a remainder. That means 4 is a factor of 24. We are going to learn rather quickly that things work out nicely. We're going to tend to prefer when we get remainders of zeros. So, let's see our first example. We've got x plus 1, and that's going to be divided out of x squared plus 3x plus 5. So this will probably be shown to you using the traditional division symbol. We're going to write it using a long division setup. All of this is going to be kind of hinging on the very first term that we see from both our dividend and our divisor. So what we want to ask ourselves is, how can I get x to go to an x squared? Or if I divided x squared by x, what would be my result? Or think of it backwards. X times what would give me an x squared? Well, the answer to that would be 1x. If I did 1x times x, I would get 1x squared. As soon as I have that, just like we did before, we're going to take that 1x, whatever we had up top, and we're going to multiply that by my divisor. So I'm going to multiply that now to the divisor of x plus 1. So when I do that, I'll get x squared and a positive 1x. Now what we need to do from here is subtract that away. Now when we subtract, it's going to be the opposite of whatever symbol you have in there. So anything positive will behave as a negative, right? So this 3 minus 1, that's actually going to be a 2. Some people find it beneficial to actually go through and rewrite it, everything getting the opposite symbol. So you do you. All right, so the x squareds will cancel. Good, we want that. Then we have 3 minus 1. So 3x minus 1x, I get 2x plus 5. Well, I'm going to do that whole process over again. I'm looking at first term, first term. What do I need to multiply to this x to get a 2x? How do I turn a plain old x into a 2x? Well, I would multiply that by a positive 2. So positive 2 goes up top as part of my quotient. And then off to the side, I'm going to write, okay, what is 2 times my divisor, which was x plus 1? What would I get there? Well, I would get 2x and a positive 2, so 2x plus 2. But we need to subtract that away, so everything is going to behave the opposite, so everything becomes the opposite. So then we simplify. 2x is canceled, that's what we want, and I'm left with a 3. That 3 is my remainder. We write our remainder over our divisor. So our remainder is 3 over x plus 1. That would be our answer. Not pretty, but that's what it is. All right, next one. Oh boy. X to the third plus 5x squared plus 7x plus 2. We're dividing out x plus 2. All right, so we're going to focus first term and first term. How do I turn an x into an x cubed? What do I multiply by? I'd multiply by 1x squared. So then off to the side, I'm going to take that x squared. I'm going to multiply it by my divisor, which was x plus 2. In doing so, I'll get x to the third. Come on now, there we go. X to the third and 2x squared. We want to subtract that away, so everything will become the opposite if we're subtracting. X to the thirds cancel. I've got 5x squared minus 2x squared. That's going to be 3x squared. The 7x, the 2, those just drop down. Now we're going to do that same process again. We're looking at the first terms here. How do I get this x to become a 3x squared? How do I turn an x into a 3x squared? Well, to do that, I'd need to multiply it by 3x. Well, then I'll take that 3x, and I'll distribute that into my divisor of x plus 2. So when I do that distribution, I'll get 3x squared plus 6x. But then we're subtracting. When you subtract, everything becomes the opposite. If done properly, things will cancel, so the 3x squareds are gone. 7x minus 6x, I get 1x plus 2. Well, now I do the same thing. How do I turn my first term of x into a 1x? What do I multiply to turn an x into an x? Well, I really don't need to multiply by anything, right? So I'm technically just multiplying by a 1. So then I'll take that 1, and off to the side, I'll multiply that into my divisor, which was x plus 2. We get x plus 2 after we do that distribution. We're doing subtraction, so I have to use the opposites. Everything cancels, which means we have a remainder of 0. Yay! If we have a remainder of 0, that means our divisor is a perfect factor. So if I was trying to factor this expression, x to the third plus 5x squared plus 7x plus 2, x plus 2 would be a perfect factor of that. Or if I were trying to graph this polynomial, I know that there would be an x-intercept at -2, since this divides out perfectly from that. Onward we go. 2x to the fourth plus 4x third minus 5x squared plus 2x minus 3. Divide that by x squared plus 2x minus 3. Holy smokes, what am I doing? Woof, all right. Put your dividing pants on. This one's going to get messy. All right, first term to first term. How do I turn an x squared into 2x to the fourth? What do I need to multiply by? I need to multiply by a 2 and an x squared. So I'm going to take that 2x squared, and I'm going to distribute that into my divisor of x squared plus 2x minus 3. When I do that, I'll get 2x to the fourth plus 4x to the third minus 6x squared. Now we need to subtract. So the fact that we're subtracting means everything becomes the opposite. 2x to the fourths cancel. Sweet, the 4x to the thirds cancel. Heck yeah. And now I've got -5 plus 6. That would be a 1, positive 1x squared. And we'll drop down the other things, 2x and minus 3. Well, so now I'm noticing that, the next term here should have been something with an x, but there was nothing there, so I can just imagine there's a 0. And now if we're looking at first term, x squared, first term 1x squared, what do I need to multiply this by to turn it into 1x squared? Well, I don't really need to multiply by anything, so just keep it as is, multiply by 1. So I'll take that 1, and I'll distribute it into x squared plus 2x plus 3. In doing so, you get x squared plus 2x plus 3. Oops, sorry, minus 3, not plus 3. Hey. And then when we find the difference, you're doing the opposite operation for all of those. Negatives become positive, positives go negative. Things cancel, life is good, remainder of 0, huzzah. So our final quotient answer there would be 2x squared plus 1. That one was actually easier than I thought it was going to be. It looks scary, but it wasn't so bad. Such is life for math. All right, home stretch, 4 more problems. So here we have 4x to the fifth plus 5, and we're dividing that by x squared minus 1. Both of these kind of skip over a bunch of terms, right? This skips the x to the third, x squared, and plain old x. When we write these out, you need to make sure that you're not skipping any single term. So if you have terms that are missing, use a 0 as a placeholder coefficient. So our dividend goes straight from an x to the fourth, so a quartic term, all the way down to a linear or a constant, but we skipped the cubic, we skipped the quadratic, we skipped the linear terms. We need to have something in place. One good thing about zeros is math tends to be easy when zeros are involved. Zeros make adding and subtracting pretty easy, and multiplying by 0, well, hey, that's just 0. So, let's get to it, shall we? We shall. How do I turn the first term into the first term? How do I turn x squared into a 4x to the fourth? What do I multiply it by to do that? Or flip-flop the thinking. What is 4x to the fourth divided by x squared? Same logic. Well, that would be 4x squared. So then I'll take that 4x squared, and off to the side, I'm going to multiply that into my divisor, which was x squared, 0x minus 1. After I do that distribution, I'll get 4x to the fourth plus 0x to the third minus 4x squared. We then have to find the difference of these, so we are subtracting. So since we're subtracting, visualize everything is the opposite now. X to the fourths cancel. 0 and 0, who cares? Over here we have 0x squared and 4x squared. Add those straight down, and I get 4x squared. drop down the x, drop down the constant, 0x and 5. So now same thing. First term, how do I turn an x squared into a 4x squared? Well, I just multiply it by 4. So then I'll take that 4, and I'll multiply that into my divisor of x squared plus 0x minus 1. Just like before, we're doing the same thing over and over and over. When I do that, I will get 4x squared plus 0x minus 4. To find the difference, we will do the opposite operation for every term. First terms should cancel if you did it correctly. 0 and 0, who cares? And we've got a remainder of 9. Since it's a positive 9, it'll be a plus 9 over my divisor, x squared minus 1. You'll notice when I write this out, there's a gap that kind of forms. The reason why I prefer to do that is I like to have all of the things kind of lined up with one another. So I kind of visualize all of these terms kind of being in their own little lane as I go through. So that's kind of why I left this gap in my quotient there. Yeah, okay. Last problem, home stretch, here we go. We've got 2x to the 5th minus 8x to the 4th plus 2x cubed plus x squared divided by 2x to the 3rd plus 1. There's a lot of missing terms, which is why there's a lot of zeros showing up. Okay, if you ever have a missing term, you gotta fill it in with zeros. Our exponents need to go in descending order, counting down by ones each time. All right, so first term. What do I multiply 2x to the 3rd by in order to turn it into a 2x to the 5th? Well, I would multiply it by 1, and it needs 2 more x's, so 1x squared. I will then take that 1x squared, and I'll distribute it into my divisor of 2x to the 3rd plus 0x squared plus 0x plus 1. That's a boatload of distribution. So we're going to have 2x to the 5th. Zero's showing up, so 0x to the 4th. Let me change the zoom a bit here. Oh man, that's a nasty 5. I'm sorry. There we go. 0x to the 3rd. What else do we have? Oh, and then 1x squared. Now we need to subtract. We're finding the difference. So everything is going to be the opposite. Okay, well, what do we get when we do that? Those cancel. I've got negative 8x to the 4th. I've got 2x to the 3rd. The x squareds cancel, so 0x squared. And I drop down the 0x and the 0. So now we start this whole process over again. First term. How do I turn a 2x to the 3rd into a negative 8x to the 4th? I need to multiply that by a negative 4x. So off to the side, I'll take that negative 4x, and I'll distribute that into my divisor. My divisor. So 2x to the 3rd plus 0x squared plus 0x plus 1. We'll do our distribution and see what we get. Well, I'd have negative 8 x to the 4th, 0x to the 3rd, 0x squared, negative 4x. That's my last term. So now we're going to find the difference. Whenever we find the difference, I'm essentially changing the signs on all of the terms. The x to the 4ths cancel. Now I've got 2x cubed, 0x squared, 4x, and the 0 drops down. Now we do the whole process over. First term, how do I turn a 2x to the third into a 2x to the third? Well, I just need to multiply that by a 1. Just a plain old 1. So then off to the side, I'll take that 1, and I'll distribute that into my divisor of 2x to the third, 0x squared, 0x, and 1. When we do our distribution, we will get 2x to the third, 0x squared, 0x, and a positive 1. We find the difference, so we flip the sign on everything. For the zeros, really doesn't matter. X to the thirds cancel. X squareds cancel. 4x minus 1. At this point, since the exponent of my divisor is bigger than that of my dividend, I can no longer divide things out, so that means this is my remainder. Another way you can tell if it's your remainder is that your remainder will always come immediately after your linear term of the quotient. All right, so the remainder will always come immediately after, in this case, our constant term was a 1. So when you do this, your answer will be written in standard form, where the exponents go from high to low, descending order. So here I've got x squared, x, plain old number, immediately after is the remainder. And that's always going to be true, right? So here we did x squared, there was no x term, plain old number, remainder. Here we go x squared, x, plain old number, there was no remainder. Well, there was, remainder of 0. All right. That was the boatload of the long division problems. You know the drill, folks. If you have any questions, please let me know. And as always, good luck, have fun, be safe, roll tide.